So I have root 5 plus 2 root 6. I've told you, once you see a question that has a SURD inside another root, or the square root of a SURD, this is a SURD, I'll simply do, let everything here be the same thing as saying a plus b, root a plus b. So this is going to be the same thing as saying, let it be equal to, taking the square of both sides, I have 5 plus 2 root 6 square equals to a plus b root square. This is going to cancel this. So I have 5 plus 2 root 6 equals to root a plus b root a plus b. This is going to give me the same thing as saying root a into root a plus b, then plus b into, what is root? Okay, sorry, I forgot. This is not the same thing as bringing this thing outside. So I think we need to maintain that status quo. If you come and start bringing it outside, yeah, I know you can bring it outside because you are carrying the plus out. But let's try to do it inside here. Okay, let me just factor out. There's no problem with that. I've just checked it. So I have root a into a plus b, then plus b, so this is going to give me a plus root ab this is the same with this. So now that you've gotten that, you need to now go back and compare it with this. So remember, we have 5 plus 2 root 6. So this is all equals to a plus b plus 2 root ab. So notice that everything here is equals to this. So we can say that 5 is equals to a plus b. Then 2 root 6 is equals to 2 root ab. So root 6 is equals to root ab, and ab is equals to 6. That is what is inside. So notice that right here, over here, this can be the same thing as saying a is equals to b minus 5, and also b is equals to, 5 minus b. That is trying to make a subject of the formula, you get this. I'm trying to make b subject of the formula from this, you get this. So this can be the same thing as saying a into, replace b with that value, 5 minus a, equals to 6. So notice that it's more like saying, here we said, it's more like saying let b be equals to 5 minus a. So we now have 5a minus a squared equals to 6. And very well, this can be the same thing as saying a crossing over Okay, let's just do it this way. Minus a square plus 5a minus 6 equals to 0. So solving the indices, I'm saying this is solving the quadratic equation. Man, it's 1 p.m. I'm feeling so sleepy. So let's try to solve this. This times this is going to, a squared times 6 is going to give me minus a times minus 6 will give me 6a squared. Six minus a is 5a. So let's substitute. This is going to be something as saying minus a squared plus 6a minus a minus 6 equals to 0. So I have once I'm able to factor the first two, the second part is just always, in most cases, putting 1, then writing what you have here. Once you factor this one out, which is your a or whatever variable, the second part is just come and put 1 in most cases, then write what you have here for you. So notice that, sorry, as I'm factoring this one out, I need to check something. If notice that this is minus, so I don't go and do magic. Minus 1 times minus 6 is plus 6, which is not true. But if I have minus, yes. Okay, first of all, let's check what I did here. This thing now, 6a times minus a does not give me 6a squared again. So I think we missed it. We need to do in such a way that 6a times minus a, 6a times minus a everything looks right, but it's a bit confusing. So let's try to use our formula method. B here is 5 minus 5 plus or minus root 5 square minus 4. Then a is having a down here is the base there is 1. Then c is having minus 6 all over 2 minus 1. So I have minus 5 plus or minus root 25 minus 4 times minus 6. That should be minus 20. That should be plus 24. this should give me 49. Should be 25 plus 24, 49. So I have roots 49 plus or minus 5 all over minus 2. So I have 7. I have minus 5 plus or minus 7 all over minus 2. So I can see very well that this is the same thing as saying minus 5 plus 7 all over minus 2, which is the same thing as saying minus 12 over minus 2. Cancel, 1, 6, or so this one gives me 6, or minus 5 minus 7 all over minus 2. Sorry. Down here, if these two, what are you doing? This is going to give me minus 12. This is the one that will give me minus 12 all over minus 2, which is going to give me 6. It's very late. So this one now, this should give me, this one is supposed to give me 2. This one is supposed to give me 2 over minus 2. And that is going to be the same thing as saying minus 2. Minus 2 divided by minus 2. 2 divided by minus 2, sorry, which is going to give me 1. Yes. Which is going to give me minus 1. So I have 2 divided by, yes. So I simply have, I'm going to have minus 1. I'm going to have minus 1 or 6 as my value. Minus 1 or 6. And that is the same thing as saying, when I'll go back and see, remember we substituted b to be this 5 minus a. So we've solved now. Notice that everything we solved here, is with a. That is here. When we got to this point, this is a square 5a. So it's a that we got. So when a is equals to minus 1, we'll have b to be equals to, b is 5 minus a. We'll have b to be equals to 5 minus 1, which is the same thing as saying 5 plus 1, which is equals to 6. Then when a is equals to 6, we'll have b to be equals to 5 minus 6. B will be equals to minus 1. So very simple like that. So that means that you can go about it this way. So I know sometimes when you see this kind of question, might say you have 5 plus 2 roots 6 all raised to power 2. I might be telling you, take the square roots now. Take the square now. But you know you can't take square of one side. That is why once you see this kind of question, when you do this and you now have 5 plus 2 root 6, you simply need to compare it with a right hand side by first doing root plus b. So take the square of both sides, then solve. It's very late. This is 12 thereabout, 12:40 thereabout. So I'll solve just one question so I can go to bed. I feel so tired. So this is x minus 2 plus root x squared minus 4 equals to 0. So this can be the same thing as saying x minus 2 equals to the one with square roots go one side minus root x squared minus 4, or I can say root x squared minus 4, so I don't get things complicated for myself, equals to minus x plus 2. That is throwing it to the right hand side. So let's not get things complicated for myself. That's why I abandoned this. I didn't say it's this crossover, x crossover minus x. So I can now say take the square of both sides. This is the same thing as saying 2 minus x. So that this becomes x squared minus 4. This square will cancel the square root, equals to, so equals to 2 minus x, 2 minus x. Get to the habit of always doing this way, or use binomial theorem. Don't come and stay here and be doing magic on top of here. So this will now give me 4 minus 2x minus 2x minus plus x squared at this junction. I can collect like terms. So I have x squared minus yes, this can be the same thing as saying 4x equals to 8. Divide both sides by 4. X is equals to 2. Very simple. So you see, you need to get into the habit of knowing how to go about this. It's not hard. It's just a mentality that you need to build. So you are solving this one, this one, this one for me. This one, you will solve this one for me. Then this one, know that this one is simple, because this is simply making it crossover. 2 root y minus 5 equals to 3. 2 root y equals to 3 plus 5, 8. At this junction, we have this, divide both sides by, we have root y equals to 4. Very simple. Like, share, and subscribe. Thank you.